Hi there, welcome back. Today we are kickstarting a brand new series called Building Production Ready AI Agents Step by Step. Now, this isn't just another GenAI demo or some proof of concept project. This series is about exploring how to design and build AI agents that are structured for real world use case with reliability, modularity, and scalability in mind. So how this series is structured? We are going to walk through a real world use case step by step, from defining the right problem, choosing the right LLM, integrating real tools, adding memory, and then evaluating the agents, monitoring, deployment, and then pretty much every aspect of that matters in the real production environment. So our anchor use case for this series is going to be a sales outreach AI assistant that helps salespeople to build the sales pipeline or send out the emails to the potential leads. A great example that combines both structured data, unstructured documents, and dynamic decision making. So by end of this series, what you will walk away with? You will have a working knowledge of how to build AI agents from ground up, not just agents that work once, but agents that can survive in a real production environment. So in today episode number 1, we are going to cover the building blocks of agent, the agentic pattern with a demo, introduction to the use case we are going to build, and how we'll start approaching our real world use case. So this is going to be a really exciting series. Please follow along and stay with me till the end. You are going to learn a lot on AI agents, and also just not learning, you will have a real working knowledge where you can build agents on your own in the production ready fashion. Okay, with that, let's get started. So now let's see how these AI agents are different from traditional coding agents, right? Number one, the agents are declarative, not procedural. What I mean is that in traditional software programming, you are more of a procedural. You are writing step by step. If this condition satisfies, you do this. If a condition satisfies this, you do this. In this, for this input, invoke this API. For this input, invoke this API or this method, this database call, or this SQL query. We pre-program, it's kind of a procedural. But in case of AI agents, they are more goal based. You tell the agent, do me a weather plan, a travel plan, find me a right sales leads, and answer this question about some technical challenge customer is facing, or answer this diagnose these symptoms of a patient. So it is more of a goal based, and then agent determines what is the path forward. We don't tell the agent how to proceed, we only tell it what is the goal. And second thing is that we provide the agent the tools. Okay, this is the goal and these are the tools available with you, and agent can actually pick up the right tool based on the context, based on the question. So that's what dynamic tool use means. We'll see how the dynamic tool is going to be. Actually, I'm going to give you a demo of a React pattern where we'll see how agent can pick up the right tool depending upon the user question. Next one is learning from feedback. So agent can reflect on the results and adapt behavior, based on the response. So we will also going to see a demo of this a reflection pattern where agent produces a output, and then it reflects whether this output is actually is what user wants. If not, it try to regenerate the response. Other important aspect is the context aware execution. What it means is that agent retain the memory from the different conversations it is having with the user. So if you are building say a IT help desk agent which would help the user to troubleshoot some of the issues they're having, every time user asks a question, agent can retain like, okay, yeah, maybe an hour back or yesterday user asked a question about his monitor is not working. So today there is another issue, is this issue and that are related. Okay, so it can retain the memory, and it knows that context aware. Other one is that multi-agent collaboration. We don't have to build one, a super agent which can does everything. You can build a specialized agent. So one agent which is specialized in doing the market research, one agent which is specialized in figuring out which customers will like this particular feature, or whether this product feature is relevant for which customer. And then we could have another agent which is expert in drafting the emails. Now these three agents can collaborate, pass on the information from each other, and then it's just not like procedural. If the email draft agent in the end determines that one thing, the previous agent determines give me some output that is not sufficient, it will go back again and then ask that agent, hey, I need this information which is not available right now. That research agent will again do the research and give the information this email draft agent wants. So it is a multi-agent collaboration, but this agent can converse, they can talk to each other, right? And then and also agents plan and then reason in a way that mirrors actual human process. Actually, I'm going to show you a demo when you do reflect pattern. Just to give an example, if you are asking an agent do some task, you don't tell the agent, hey, there is a method, you need to pass 3 parameters the method to invoke it. Agent will know, yeah, agent user is asking to me search on the flights, so there is API available, and that API I need to pass the airport code and the start date, end date. So now it will invoke that method by passing these things, right? So agent is capable of doing that on its own without we actually telling agent like what method, what tools to invoke. It can make a decision based on the context and the question. So let's go step by step, right? How we use an LLM typically, just like in a chat GPT or Claude or Grok or whatever you are using, you just provide a prompt and then that gives you an output, right? It could be summarizing a document or answering a question or generating a code. It is just an interface where you just give a prompt to the LLM, it gives you an output. This is very simple, and then the base scenario which everyone is using it. Now say we want to make it little bit more intelligent, then we add some context. That means we give the context which is not learned by this LLM during the training process. That means we augment this LLM with some external data. It could be some database, it could be in some files, it could be some unstructured data, it could be anything. That's what we called a RAG application, a retrieval augmented generation application, where you have an LLM, you have a lot of data, you build the data, you have all the vector databases, context, and then you give the context for the user. Of course, I have another video explaining in detail about the RAG called Agentic RAG. So feel free to watch that if you want to get more details on RAG. Now, this will take you to some extent. This is just, it is helping you by LLM augmenting the data which you are having, so that agent LLM has got a better context of the things. Now you take step further, this is where then agent will come into picture. So now agent just not only answer your queries, it can take action, it can do the reasoning, it can plan the things, it can things like a human. Okay, that's what LLM agent will do. So if you see in agent, there are multiple components of an agent. One of the base component is that the building is LLM. So every agent needs an LLM. It could be GPT, it could be Anthropic Claude, or it could be Mistral, it could be DeepSeek, it could be any other LLM which provides you that base LLM which the agent will use for the reasoning. Now these agents are developed using different frameworks. We have a lot of frameworks in the market like LangChain, Crew AI, Microsoft AutoGen. Like we have various type of frameworks which are available to use. For now, assume that agent is built. We are not talking about any framework. Now Second important component of an agent is a tools. So what is a tool? A tool is a mechanism for agent to perform an action. For example, if the agent is a travel assistant agent, it will have the tools like searching the flight, searching the weather, searching the local places. So if the agent is an IT help desk agent, it will have the tools about checking the error codes, checking the internet connection, or checking some hardware issues, right? It will have different tools like that. So what is these tools? And eventually, for now, assume that these tools could be anything. They could be some API calls, or it could be some pre-built functions which agent might invoke. So it could be anything agent will use as part of its reasoning process. Okay, and now agent also has access to some data. It needs some context. So when performing some operation, it needs some access to both a structured and unstructured data. That's what the data and document required by the user. And then we are giving agent to perform certain tasks. So every agent will say you do only this, don't go beyond this, because we are defining the boundaries for the agent. As a support assistant agent, your job is to only troubleshoot, or maybe as a in a healthcare agent, your problem is only to get the symptoms from the user and see the mapping, whether is there any similar symptoms, what is the root cause analysis for that, right? So it could be we are just defining the scope of the agent through the task. And then every agent has got some output. So and then one agent, along with an LLM model, it can also use other machine learning models also as one of the, for example, you want to do the fraud detection and you already have an ML model which does fraud detection. So this agent can also leverage another ML model as one of its to perform some tasks. So to summarize, an agent is an intelligent system that can do the reasoning. It has got context, it can retain the memory across conversations, and the core building blocks of an agent is number one, an LLM. Every agent requires a foundation model. Number two, an agent requires tools. These tools could be APIs, which, or maybe it could be another agents also. Like you are having a drafting agent which would take the input from a research agent, right? So it could also talk to another agent. That's where we have now this Google API protocol where one agent can actually communicate with other agents, right? So I also made a video on Google API protocol. Please feel free to watch it if you want to get more details about how one agent can communicate with other agent in a very standardized way. So these are the core building blocks of the agent. After this, we are going to see some of the agentic patterns and then a demo of the agentic patterns. In fact, when you see the demo, you will actually really understand what I mean by the tool and what I mean by the reasoning, how agent can think like human being. So we see all these things in action in the coming slides. So before we actually go and build the AI agents, but let's see, when does it make sense to build an agent? So building an AI agent is, it's just not about using some LLM. It requires rethinking how our systems make a decision, especially in areas where conventional automation struggles. So if you see, traditional systems work like a checklist. They follow fixed rules. For example, in a payment fraud detection system, a rule engine might flag a transaction that are over certain amount from a specific location or involve certain keywords. But an LLM powered agent works differently. It thinks more like a human being, like it can evaluate the pattern, weigh multiple subtle signals, and make a judgment even if none of the obvious rules are violated. So where does agent actually shine? Okay, first, in workflow that involves complex decision making, things like a refund in customer service. These situations don't follow strict yes or no logic. You need to understand the context, interpret customer sentiment, or consider the past history. So agents are perfect for this. Second, when your existing system relies on very complex and hard to maintain rules. If I got a workflow with hundreds of if else conditions or exception overrides, that is strong signal it might be time to rethink with agents. A good example here is like a vendor risk reviews. Something like a compliance rule changes all the time and encoding every variation in static logic gets messy, right? This is where you can provide all that rules to the agents, in the form of either unstructured text or a structured text, and agent can determine how based on the rule, right? Third is when you are dealing with a unstructured data like long emails or PDFs or customer messages or claim documents, traditional automation breaks here, right? For example, if you want to make a decision whether this particular claim raised by the user actually as per the claim rules, and then all the claim rules are there in a big PDF document, traditional systems might not work here. This is where agents will shine. Like you can give entire PDF rules to the customer and to the agent, and agent say, hey, customer raises claim, this is my set of rules, does it claim meets this criteria, right? So because agents, especially the retrieval and memory, can understand and act on this kind of information more effectively than a form based systems. So the bottom line is use agents when your automation needs to reason, adopt and understand, not just follow rules. Okay, but if you're having a simple rule based system which is not going to change, or maybe sometime your system requires a lot of human input, lot of human intervention between, that might not be a right candidate for the agent, right? So we need to see like what is the right use case for the agent, evaluate on different parameters. Lot of times that use case could be a case by case basis. We need to evaluate based on different parameters and then make a decision. So basically the decision making, the rules or the structure of the data are three guiding principles which help you decide whether agents are the right candidate for this use case. So now we learned about what are the building blocks of agent, like the LLM, the tools, the memory, the task, and what they perform. Now we'll see some agentic patterns. What are the different ways you can build these agents? We'll see a react pattern, a reflection pattern, a multi-agent pattern, and we'll also see a demo for each so that you will get a clear understanding of what this pattern is all about. So now let's start with one of the most popular agentic pattern called react pattern, which is short for reasoning and acting. Unlike traditional chatbots that just generate response once and stop, a react agent goes through an intentional iterative cycle. So what does it mean? It first does a thought. This is where agent reasons about the current input. It decides what needs to be done next, what information is missing, and what tool it might help. Say for example, if you're building the example you are going to see next, you are building say a troubleshooting agent and help desk agent. If the user says my monitor is stopped not working as flickering, agents first look at the question and applies a thought. The user is asking this question, so what should I do next, right? Then based on the thought it will take the action. So based on its reasoning, the agent might choose a tool, maybe an API or a database query or a document retriever, and perform the action. And step number 3, it will do the observation. So agent looks at the results of the action. Was the query successful? Did the tool return the data it needed? It reflects on this outcome and decide the next step. So this goes in a loop till it actually answers the user question. Okay, thought, what user is asking. Okay, then it does what is the next immediate action I need to take. Okay, let me take this action. Now it got the result. Say for example, I will take the same example again. Like if you want to have a travel agent, user says travel me trip from say Dallas to Paris from these days to these dates. It will first goes and checks the flights, and then after that does observation. I have only the flight. Is that enough? No, I need hotel information also. Let me go and then invoke the hotel API. Now I got the flight and hotel. Is that enough? Let me also need to plan some activities, to generate the itinerary. So it will go and invoke another API. So it does this thought action observation cycle until it reaches a point where it has got all the information. It is ready to give the output to the user. So this structure gives the agent a kind of a shorter memory and control flow, allowing it to make decisions step by step rather than guessing everything in one go. So it is ideal where the agents need to combine reasoning with the tool use, deal with incomplete information, adjust its plan based on what it learns. So basically user is passing some input and then it invoked an API with that input. The API threw an error with some error code saying that this information is missing. Now agent will know that user didn't pass information, it is missing. Now it can take a decision. Do I need to ask the agent to enter this information, or is it available somewhere else? And then I can use that information. So basically it can do the reasoning based on the tools available, right? So this is what a React agent is all about. So now let's see when it actually makes sense to use a React agent. It is very popular pattern which is used in a lot of places. So instead of traditional script or deterministic logic, when it makes sense to use this. Number one, if the environment is uncertain, when outcomes are unknown upfront, think of situation like web search or customer queries or troubleshooting where you need to explore the unknown. And other one is that if you want to make a decisions dynamically, when the next step depends on what just happened. Okay, I found that there's an issue with the network, so based on this, what step I need to take, right? Maybe your agent is filling out a form or solving a step-by-step puzzle, it needs to adapt. And next one is tool-based reasoning, when the agent needs to use APIs, look up database, or call other services to gather information before it can respond. Number three is thought action cycle. If solving the task requires back and forth reasoning like research or debugging or customer Q&A, this is where React shines. Then on the right side, if you see in the diagram, we have outlined the core benefits of using React agent. Number one, it supports iterative reasoning. It thinks in a loop, not just in a straight line. It enables a tool augmented decisions. The agent doesn't just think, it can do. It uses observational feedback, adjusting based on what it sees. It was great for open-ended tasks, no clear path, many possible answers. And finally, it's built for a goal-oriented autonomy. Agents that think in terms of goals, not some type of a hard-coded instructions. So if your use case needs flexible thinking, external tool usage, and learning as it goes, then the React agent is what you should be using. That will be the right fit in that case. So next, we will see a quick demo of a React agent, how the React agent work. So I'll walk you through a simple example in a Jupyter Notebook so that you will see the step-by-step process of building this agent. So I have this Jupyter Notebook here. Okay, I already have just setting all the API keys, open API keys, everything in the environment variable. So I'm just trying to load them here. And then of course I'm not going to do this because I have already installed all this LangChain, LangGraph, LangChain required. We'll be using a React agent from LangChain, which is kind of easier to build, and then I can quickly show you how the thinking process. So this is what I'm going to use the OpenAI GPT. So that's why we need to import chart OpenAI, and then we are having this pre-built create React agent, which we can use it here. So we'll do that importing, and then I'm setting some LangChain API keys, LangSafe API keys, and also demo so that it will help for me for tracing. And this is the important part. So I'm building 3 tools. Of course, I'm hard coding all the things. So we are building an IT help desk agent where someone can ask a question about some issue they're having. The agent will determine what is the root cause and give the response for the user. So I'm building a tool called check internet connection, which will check the internet connection. I'm building a tool called diagnose hardware. I'm building a tool called error code. If you can see, all of them are having this decorator called a tool, which will tell that agent that this is a tool. And then if you see everywhere, we are actually giving some instruction. This is how agent understand what is the purpose of this particular tool, and then it knows whether it has to invoke this tool depending upon the user question, right? So next, now I'm going to run this cell. So now I have all my tools ready. So I'm having 3 tools, each tools perform a different task. So if it is not in the real world, this could be, each tool could be invoking some external APIs, or it could be doing some database lookup internally, or it could be in fact a RAG tool, which is actually invoking another retriever augment generation app to get the data, right? So next, I'm actually having this chat open API. We are LLM. So you can see that I'm passing the model, temperature, and then I'm passing API key. That means I'm creating an LLM here. Now I'm creating an array where I'm passing all my tools like check internet status, diagnose hardware. You can see we defined all the tools over here. We are just creating these tools over here. We are just creating an array of these tools. And now I'm initializing this agent. So you can see that we have initialized this agent called initialize agent. So what are the tools I'm passed? I'm passing that tools here. The tools are declared over here, and then I'm saying LLM, and then I'm saying it is a structured chat React description agent type. So LangChain has got multiple agent types. You can actually refer the what agent types you can pass over here depending upon your use case. You can say I want to use different agent types. In this case, I am passing this, means what it tells is that it is a React agent. There is a slight change now. You can also use a LangGraph instead of using LangChain here. That will help you, but I want to show you the concept behind the React agent, so I just built it using LangChain. But LangChain, I think nowadays they encourage all of them to use a LangGraph React agent instead of LangChain. So to keep it in consistence with their with the LangGraph. If you want to use LangGraph, it kind of makes this easier. So I'm just ignoring some warnings. Okay, now I have the agent ready. I'm ready to ask the question. Now the question I'm asking is, I'm using my laptop at home, the internet is slow, I'm also seeing error code 42, can you help, right? So you can see here, nowhere we don't have any procedural or structure. We defined bunch of tools we are passing. Let's see how this agent actually now thinks. So now when I execute this, of course you see this warnings because of for some reasons it is not Langsmith. So now you can see it is in the thought phase. The thought phase, it says the user has reported 2 issues. Okay, let's first check the internet status at user location. So to check the internet, it is performing an action. The action is check internet status. If you remember, this is a tool it is using, and action input is home because it is determining what parameter to pass to this method based on the user question. User said home, so it is passing home, right? Now internet connection at home is unstable, packet loss detected. That's what the output it got because we defined like that. Now it is going in thought cycle because it is not done with it. One user also said I'm getting this error code ER42. Now it is again going, the user connection is unstable, which could be caused a slow connection. Okay, before we address this, let's also look up at the error code ER42, understand what it means, if it could be related to internet issue. Now it goes to the error code and it says graphic driver crash, solution reinstall GPU driver. This is what it gets from the by invoking this tool. Now it does again a thought. The error code is not related to internet issue, so user will need to install all the things. It does all the things and it gives you the final output that your internet connection is slow. Then restart your router, like it gives you all the instruction user. If you can see, we just passed only one question, and then the agent is able to figure out what tools to invoke and how to invoke, what parameters to pass, everything. We are not giving any. This is what I mean when it says this is not a procedural, it is more of a goal based. So the goal here is to troubleshoot an issue, and then agent is using the, and then all we should do is give the agent the tools it require, and then agent can pick up, because the agent is powered by an LLM, and LLMs are good at reasoning based on the text. So this is about the React agent. We will again come back to this demo to see another agent pattern called reflection pattern, and we'll see the same example how the agent will do the reflect on the question response. So now let's explore another agentic pattern called a reflection pattern. So what is the reflection pattern is, one agent will do the reasoning the way we did, like it does a thought action cycle, and there is another agent which will judge it whether this response it is giving to the user is correct or not. It is called reflection. That is, this also we call LLM as a judge, where you have one LLM doing the action, another LLM is judging it. Now you could have these two LLMs could be different. You could build an LLM, you can fine tune that LLM just to to observe, to tell whether this particular response is correct or not, right? So for example, if you take you take any LLM and then you fine tune the LLM for a variety of user questions and answers, and what is an actual a good response looks like, and then you find in LLM, hey, if the response is this, the usage is as a good, if this response is this is not good, you need to rethink, like that. You find in LLM and then you make that as a judge, right? That way you can actually customize your whenever your agent gives an output, that agent can figure out whether that output is actually correct or not. It has been fine-tuned, it is only judging, so that because it excels in judging rather than doing the task. So how does a self-reflecting agent work? Same thing, we have same user prompt, it goes to LLM, and LLM gives an agent gives an output, and then we give that output to another LLM, a critical LLM, which will tell whether this particular output is actually meeting its context, for the user question, for the context, whether this output is actually good output. If not, it will say this is not good, then it again goes back to LLM. This LLM will again reflect on the response given by critical LLM and try to adjust its input or its reasoning based on that, right? So that's where this cycle keeps on going till it arrives at an answer, and then it gives a response back to the user. Now what we'll do is we'll take the same IT help desk agent what we showed demo in the previous demo. We will add the self-reflecting capabilities for the same agent and see how it works. That's what I'm going to show you in the next demo. So in previous demo we have this agent which took this action, right? Now let's see if at all I want to build a reflecting agent. So basically I wrote another method called a reflect and answers. So the prompt is that basically user asks this question, okay, and then the answer is this. Was this answer helpful, complete and accurate based on user question? Respond only with yes or no and briefly explain why. Of course this prompt we can do based on what our scenario. We can enhance it prompt further to pinpoint exactly, depending upon the complexity of the response. It can tell, hey, this part of the response is wrong, this part of the response needs improvement, this is good, or this is deviating from the facts, right? So we can improve on that. Now this will return, in this case I wrote maybe simply returns yes or no back to the user. Now what we'll do is initially we'll run this agent, okay, then we pass this answer to this agent, it will do, and then it will do the reflection, okay. Now we are having next question. I'm using a desktop at office, it's showing error and I can't connect to the internet. Now let's see what happens. Okay, let me run these cells. So this is a reflecting agent. We'll run this one also, and then we'll run, this is a query. Now let's run the self-reflecting agent. So now it is at a first attempt entering agent execution. It is saying it is doing thought cycle here. I should first look up error code and what it represents. So error code, it says server unreachable, solution check network firewall. Okay, and then okay, it is using this tool. Okay, now it is doing the typical the React agent what we did. Now since the internet office is unstable, there is no packet loss, so it is again diagnosing the hardware action. Now after doing all this thing, it has finished this chain. Now reflecting, okay, now if you can see that this reflecting agent has replied back. It said yes, the answer is helpful, complete and accurate. It identifies potential problems. It is saying the suggestion about the learning the everything. It just giving all the response back. Now it is giving some suggestion about the learning the desktop GPF and all the not directly to the error code. See, basically saying you did a good job, but it is also giving you the some type of a suggestion that you can still improve on it better. Now agent is again going back to its reasoning cycle. Okay, and then after doing all these things, it again goes back to reason cycle, and then it gives the final answer, saying that now based on that the final answer is this. It gives the error code, and it also tells that you should do some cleaning of the GPU fans, like dust in everything, all that, because our critic agent has told that you could also suggest these things to the user. So this is a self reflecting agent, where one agent, as I told again, typically this agent what I'm using for the self reflection could be a different LLM than the LLM I'm using. So I'm using GPT, or I'm using DeepSeek or an agent for doing this, or I could actually fine tune another LLM who's specialized in judging certain responses. It knows like what responses are correct, what responses need the improvement. It can judge based on that, and then we can use that LLM for judging. That way you are like building another checkpoint, so that LLMs another times they hallucinate a lot, so it might assume certain things. So that's one of the reason having the tools, having LLM reflection will help to reduce that hallucination. So the next agentic pattern what you're having is multi-agent collaboration pattern. This is where you have multiple agents collaborating, just like you're having a supervisor agent. There is a one agent called research agent, an editor agent, and drafting agent, and then these agents can talk to each other, or they can talk to the research supervisor agent, which will assign a task to each one of them, and then collects the the information from all these agents and then use this. So one of the good framework for this type of multi-agent collaboration is Crui AI. That framework actually excels in managing multi-agent collaboration. So of course LangGraph and AutoGen also have that, but Crui AI basically has got that built-in mechanisms where it makes a bit easier to develop a multi-agent collaboration using Crui AI. So this is one agentic pattern which is very powerful pattern. In fact, we are going to use this pattern in our use case. So we'll be developing a multi-agent system as part of our use case development as we go along. So and then you will see how to build this multi-agent collaboration in action. And we'll also go through the process of what framework we have to choose and what are the decision points before we choosing a framework. So we'll discuss all these things. So now let's discuss about the use case we'll be building in next few weeks about the agent we are going to build. So we are going to build a conversational sales outreach assistant. Basically, what is the business context here is that sales and marketing team oftentimes struggles with manually collecting the lead criteria, using multiple tools to research companies, or maybe writing a personalized outreach emails, or staying in with the consistent messaging and strategy, and being up to date with what is happening in the market trends, right? So you want to have very consistent outreach irrespective of the salesperson dealing. So there should be a common messaging, the branding and everything should should help. So this will help you for you will have very consistent what are, with this context some of the challenges is that the outreach is quality is very inconsistent, and then you will have the slow campaign turnaround, and sometimes because of this we might miss some of the opportunities with some customers. So with this context in mind, so what we are going to build is in our multi-agent system. So we are going to build a chat based in AI assistant that helps to generate end-to-end sales outreach campaigns. So basically it starts with a simple prompt like, hey, I want to reach all the healthcare companies in this particular geography, or maybe who are interested in this particular product or this service. Then it will basically then the multiple agents work in the background. They will collect the details about the then the industry, region, buyer, the part, everything. Then you have the agent working. One agent could be working on getting the information about the companies. Another agent could be getting information about the latest market trends, and then the research, does the research. And another agent could be collecting information about what are the products which are suitable for this customer. And then another agent could be collecting information about the messaging part, the messaging guidelines, or the brand guidelines and everything. And then there'll be another agent which is going to put all this information together and generate a sales outreach email, right? So this is what we are going to build in next coming few weeks. And then we are going to see, the most important thing is that what is the process of building this agent. That is what we are going to focus more on, right? So and then this will really help the companies because it helps to cut their time for any campaigning, or it ensures it makes sure that your message is very consistent. And then it also enables anyone to generate some sort of high quality campaigns or outreach emails from scratch. And it also consider it has got like 360 degrees of information. Like it considers the customer, and then it is consider current products, your messaging communication guidelines, strategy, your branding, everything. And then it is very customized for every customer. You are not sending some outreach email, same email to every customer. You are actually customizing based on the trends in that particular in industry for that company, what is happening. Based on that, you are actually generating the right email to target the specific customer. So this is what our agent is going to do, and this is what we'll be building in next few weeks. So moving on, so this is how typical a mock UI type of looks, where a sales rep or a marketing person can come and ask, I want to do this agent will collect all the information. And then we have multiple, I just put some 3 agents here, but we need to see like how many agents we require. That we'll explore as part of our design process, like what agents are required, what tools it has to use, and everything. Will be exploring them, how to build them. So that's what we'll be doing in the coming weeks, right? So moving on, this is what we'll be doing next. So we are in the week 1, we laid the foundation. We just understood what are the basic agent concept. We saw some agentic patterns. We saw some demo on the React and Reflect patterns. We saw some simple LangChain React and reflection patterns. Now we have defined our use case. Okay, next session we are going to look at the the planning part, like what LLM I require, how do I choose my LLM in the first place, what tools I require, what APIs I require, whether do I need to have a conversational memory, like what memory options I have, can I use the something like LangChain memory or Zep memory, right? And then we'll also select what prompt tools we use to manage our prompts or version our prompts. So we are going to look at how are the tools, are we going to use some MCP servers, are we going to build some ATA protocol for agents to communicate. So we are going to look at every design options in the next week, and then by end of next week we'll have an architecture ready for us to start the development. Okay, so that brings to the end of this session 1 of this series. Please watch out for my next video about architectural planning. This is going to be a really interesting session where we'll explore an end-to-end architectures, right from the user deciding LLM to even including your how we are going to do the versioning of the models, how do you deployment, how does what UI we build. So we are going to look at every aspect of building this production ready agent, right? So with that, this brings to the end of the session. Thanks for staying with me till here, and then see you again in the next session. Thank you.